Hey boys and girls, this is Volume 1, Module 8, Lesson 3, pages 191 through 194 in your workbook, and this is representing multiplication with unit fractions. Now you might need to be watching this video because maybe you need some extra help, or maybe you just want to review it again, or perhaps you were absent. Now the I can statement in this is, I can solve a problem by multiplying a unit fraction using a visual model. And so our key word in there that we want to look at is unit fraction. What is a unit fraction? Okay, we have talked a little bit about a unit fraction and recalled from 4th grade that unit fractions are those fractions that have a numerator of 1. Now the denominator can be any number, but the numerator would be 1. And what does a unit fraction mean? It simply means it's the size of the piece that we're measuring something with. For example, if I have a shape that's divided up into 3 equal parts, and this is equal to 1 whole, each of these would be considered thirds. So that's the size of the piece that I'm measuring with, thirds. If I wanted to decompose a number, a fraction like 3/4, that simply means the size of the piece I'm measuring with is fourths, and the number of those pieces I have is 3. So I could decompose this into my unit fractions of fourth. Oops, just 3 of them. All right, so a unit fraction is a fraction that has a 1 as a numerator, and the denominator tells us the size of the pieces that we are measuring with. Okay, in this particular lesson, we wanted to multiply unit fractions using a visual model. So we're going to read through the problem. A chef uses 1/4 of a package of dough. Before using this part of the package of dough, she cuts it into thirds. What fraction of the whole package is each of these smaller pieces? So I know she's going to start out with 1/4 of a package of dough. And she's going to take that 1/4 of a package and cut it into thirds, 3 different equal sized pieces. And I want to know this question: what fraction of a whole package is each of these smaller pieces? So I want to start by drawing a model of 1/4, the 1/4 pack of dough. And I want to do that by partitioning this off into 4 equal parts. So this represents my 1/4 of a package of dough. And then I want to cut it into thirds. So I'm going to divide this section into 1/3, and then another third, and then my 3/3. So each of these, 1/3, and then 2/3, and then 3/3 of that particular 1/4 of a pack of dough. My question asks, what fraction of a whole package is each of these smaller pieces? Well, I can see that these smaller pieces are each 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each of these smaller pieces is equal to 1/12 of the whole package, if I relate that back. It asks here, how does the word thirds in the word problem help you to set up your visual model? Well, I know that thirds is referring to 3 equal parts. So each of those parts would be 1/3, which is what I divided my 1/4 of a package up into. Okay, let's take a look at the next problem. In this question, we want to build understanding. Only 1/3 of a chef's specialty pizza is left at closing time. And so we see 1/3 of the pizza is left over here. And I know that they're drawing 1/3 because I can see that that would, if I marked this out into equal parts, that's 1/3 of the pizza that's left over. Of this 1/3 of a pizza, the chef eats half of this leftover pizza. So there's only 1/3 of a pizza left, and the chef is going to eat half of it. And I want to know how much of the whole pizza does the chef eat. So it's asking us, once I cut this in half and the chef eats this section right here, I want to know how big is that piece. Now remember, it's being related back to the whole pizza. Yes, he did eat half of this piece here, but if I relate it back to the whole pizza, I know that a fraction means it has to be divided into equal sized parts. So if I divide this into 2, then I would divide this into 2, and then this one into 2. And I would see that the chef ate 1 out of 1, 2, 3, 4, 5, 6. So the chef ate 1/6 of the whole pizza. All right, so let's step that out again. The chef has 1/3 of a pizza left over. That's the 1/3 left over. Now, the chef eats half of it. So I'm going to come over here on the width side, and I'm going to cut it in half. All right, and so I know he's going to eat one of those 2 pieces. He's going to eat 1/2 of it. And that size of that piece right there is 1 out of 1, 2, 3, 4, 5, 6. All right, now even though none of this pizza is left, I still want to cut it up so that I know what size that small piece is equal to. It asks here, how do you name the fraction of the whole pizza that the chef eats? Well, I name it 1/6 of a pizza. Of the whole pizza, it's 1/6 of it. How do I know? Well, because I am taking 1/2 of the 1/3, and I know that that's going to be a smaller piece than a third, which is a 6. What part of the whole pizza does he eat? Write an equation to model the problem. All right, when I write this equation, I know that of means multiply. And so I'm going to write the chef ate 1/2 of the 1/3 of a pizza. And I know that 1 times 1 is 1, and 2 times 3 is 6. So I'm checking it with the computation. When you multiply fractions, you multiply numerator times the numerator and denominator times the denominator to get your answer. And I look at that answer and ask, should it be reduced or simplified in some way? And this one does not simplify. Okay, on page 193, number 2 at the top. The chef also makes a stromboli. 1 serving of a stromboli is, 1 serving is half of a stromboli. What fraction of a meter is the length of 1 serving? So when the chef bakes 1 whole stromboli, the whole thing is 1/4 of a meter long. Now he doesn't serve this entire sandwich for a serving. He cuts it in half and serves this much of it. And so I want to know what fraction of a meter is this serving here. So I see that it's going to be only half of, it's going to be half of the 1/4 of a meter. And they wanted to show this on a number line. Well, here's 1 whole meter right there. This stromboli, the whole thing right here, is only 1/4 of a meter long. So I want to show that on my number line. That's 1/2 of a meter. Now I've divided it into fourths, so I know that this is 1/4 of a meter right there. All right, and I divided that into 4 equal parts. That's how I know that's 1/4. Now the chef takes a 1/4 meter size sandwich and cuts it in half. And this is going to show what part of a meter that the serving size is. So how big is this? Well, I can see if I cut this 1/4 into 2 equal pieces, then I need to do the same here to keep these all the same size. Now when I do that, I can see that now my 1 meter has been divided into 1, 2, 3, 4, 5, 6, 7, 8 segments. It's divided into 8 line segments. And so I know that this section up here is going to be 1/8 of a meter. So I know that 1/2 of this 1/4 meter sandwich, this half here is going to be 1/8 of a meter long. What fraction of a meter is one serving of stromboli, and how do I know? Well, I know that this one serving of stromboli is going to be 1/8 of a meter. How do I know? Because 1/2 of 1/4 meter is equal to 1/8. All right, and it says write an equation to model that problem. Well, that's exactly what we did up here. This is an equation. The equation is made up of numbers and operations and an equal sign, and then I solve it. Let's go down to the check understanding. The chef makes a rectangular pizza. At closing time, 1/6 of the pizza is left. The chef eats half of the leftover pizza. Draw a visual model to find the fraction of a whole pizza that the chef eats. And then write an equation to model the problem. All right, let me go back to the beginning of this and see how much pizza is left over. 1/6 of a pizza. I can model that by drawing my rectangle and then dividing it into 6 equal parts. And then I'm going to just shade in 1/6. All right, now I can see all these marks in the pan from where he can make cuts and left little scratches in the pan, but all this is gone now, and only that much pizza is left. The chef eats half of the leftover pizza. Now, the only piece of pizza is this, and he's going to cut it in half right there, and he's going to eat that much. But so I know what size this is, I'm going to have to think, okay, if it's this size, these are not the same size as that. So I need to cut this all the way across so that they are partitioned equally. Now I know what my new denominator is. This was 1/6. This is half of that. And I can see that it's going to equal that piece he ate is going to equal 1/12, because it's now 12 equal size pieces. The size of that piece is 1 out of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the size of the pizza he ate is 1/12 of the whole pizza, because it's related back to the whole thing. Write an equation to model it. Well, I know that there was 1/6 of the pizza left over, and I use that as my second factor. And he ate 1/2 of that 1/6 of a pizza. 1 times 1 is 1, and 2 times 6 is 12. He ate 1/12 of a pizza. In number 2, it says to use a number line to show 1/5 times 1/2. All right, so what I know I need to do is I'm going to look at my second factor, and I'm going to say I have 1/2 of this number line. This is 1/2. So that's what I'm starting with. And of this 1/2, I need to show what is 1/5 of it. Well, to show 1/5 of it, I'm going to have to divide it up into 5 equal parts. 5 segments, 1, 2, 3, 4, 5. And I'm going to pretend like those are all equal. So I've divided it up into 5 equal parts. Now I want to know how big is one of these segments. How big is that segment? Well, if I'm going to use my picture here, I'm going to have to say, well, if this side is divided into 5 equal parts, and this is my whole unit, I need to divide this side into 5 equal parts also. 1, 2, 3, 4, 5. So altogether now I've divided into 10 equal parts. So each of these are equal to 1/10. So this is 1/10. So 1/5 of a half is equal to 1/10. And I can write an equation for that too. This is my model. Here's the equation. 1/5 of 1/2 is equal to 1 times 1 is 1, and 5 times 2 is 10. 1/5 of 1/2 is equal to 1/10. Okay, let's look at the on your own problem. A customer designer cuts the section of ribbon shown into fourths. So I'm looking at this amount shown. It's 1/4 of a foot. And it's not a customer, it's a costume designer. So he takes that 1/4 of a foot of ribbon and he's going to cut it into 4 parts. What fraction of a foot is each piece? Okay, well, I know that this is going to be 1/4 of a foot. So 1 whole foot would be right here. I need a bigger spot to draw that. Okay, here's my number line. And I need to show 1 whole foot, so 0 to 1. So on my number line, I need to show a fourth. I divide it into 4 equal parts, so this is my 1/4. And that represents this little piece of ribbon right here, from here to here. Now it says this costume designer is going to divide that into 4 equal parts. All right, so I'm going to take a pointier pencil and I'm going to divide this into the 4 equal parts, into fourths. So that's going to be 1, 2, 3, 4. It's now divided into 4 equal parts. But what size is that? Well, I can't say 1, 2, 3, 4, 5, 6, 7. I can't say, oh, it's a 7. What do I need to do? Well, if this one is divided in 4 equal parts here, I have to do the same thing to each of these sections so that each part is divided out equally. I divided that part into 4 equal parts. This part is divided into 4 equal parts. And that part is divided into 4 equal parts. Because a fraction is a part of a whole unit, not just a part of another fraction. So in order to name the size of that piece, I would have to say, well, how many parts are in there now? Well, that's 4, 8, 12, 16. The 16 different parts. So I know that one section is going to be 1/16 of a foot. Can I write an equation for this? I can. I'm finding what is 1/4 of 1/4 of a foot, which means multiply. 1 times 1 is 1, and 4 times 4 is 16. So I know my answer is going to be 1/16 of a foot. Okay, I want you to try number 4 and number 5 on your own. It's a good idea to read through these 3 times. The first time, read through it, identify your question, and then go back into the story to see what information you would need to answer that type of a question. These bullets are going to give you some suggestions to help you. You can use a number line, you can draw a picture, you can write an equation to solve the problems. Okay, good luck on that. Ask questions. Bye-bye.